Okay, right. So we've given it a couple of minutes for everybody else to manage to get in. So today we're going to be talking about how ProCal can assist with calculating your uncertainties and go into some of the elements in quite a degree of depth to explain how you would create an uncertainty budget using ProCal, viewing the uncertainty calculation in ProCal, and showing the dynamicness of the system. So if we adapt the procedure, what will happen, and how you can verify the budget yourself that it's generating. So at any point, please feel free to ask questions. This is an open forum for your questions. If I feel the question is good for the rest of the group, I will read it out loud. Otherwise, I'll try to answer them at the end or via email after the session ends. So the first question is, yes, this webinar is being recorded, as was the earlier session, in case that one turns out to be better. So you'll be able to share it amongst your colleagues later. Okay, so the learning objectives for today are to view a dynamic uncertainty calculation for a meter and a measurement type test. What we mean by a meter type test is something that ProCal is controlling a source, so such as a where you're calibrating using a source. So you're calibrating a handheld multimeter, and then you've got a measurement type test, so where you're calibrating where you are using a multimeter to measure something like a resistance box. We're going to observe the process of viewing and adjusting an uncertainty table for an instrument. We're going to observe the process of viewing and adjusting an uncertainty template, and we're going to review the effects of resolution and other contributions on the expanded uncertainty. So I'm going to start off the session with a poll as a little bit of audience participation, just so I know what the level of audience we're talking to this afternoon is, and so I can tailor some of the session. So I've just started the poll. Okay, so I'm just going to wait for about 3/4 of the audience to have a response, as I know we've been having a couple of issues with lag and delay on the webinar this morning, so I don't know if that's continuing this afternoon. Okay, so we're just sitting at about that number, so I'm just about to close the poll. So I'd just like to share the numbers with you, just so you'll get an idea of the kind of group we are today. So it's looking about half of you using ProCal, and then everybody else is using a mixture of either no software, other, or MetCal. So hopefully this session will be useful for the whole audience. So the whole goal is for this to be useful for everybody here this afternoon. So ProCal features a powerful dynamic uncertainty calculation that allows users to customize uncertainties and create templates. So some of these terms where we're talking templates, uncertainty tables, we're going to be covering that and explaining what we mean by an uncertainty template in the software. So ProCal calculates uncertainties as detailed in M3003, the expression of uncertainty and confidence in measurement, normally abbreviated to GUM. There's a link in the PDF to the UCAS version, the originator of this file, and ProCal uses this format for the display of uncertainties and the calculation of uncertainties. Most quality systems that are to 17025, it doesn't matter if you're UCAS, NavLab, A2LA, will use this format. So when ProCal is calculating uncertainties, the first element we mention is uncertainty templates. So each uncertainty, each measurement type or source type that ProCal performs and calculates must have an uncertainty template associated with it. This template allows the user to enter all of the contributions to the final uncertainty and customize the elements depending upon the measurement or sources being made. So ProCal, the default installation, ships with default uncertainties for most test types, which include basic information and example uncertainties, but they're by no means complete, as that's for the user to match up with their existing uncertainties and their contributions. So all uncertainty templates have 4 fixed contributions, which we're then going to walk through. So I've got a picture here, which I'll annotate, showing what we mean by an uncertainty template. Let's get my pen. So on the left-hand side of the screen, different color this afternoon, we have our uncertainty templates. So this is the list of all of the templates that ProCal can use in a test or when we're writing a procedure. And over on the right-hand side, we have our list of contributions. So the first 4 are grayed out. They can't be edited because they're calculated during runtime. The remaining 15 can be configured by the user. So you can have a very complicated budget, or you can have quite a simple budget, such as this one where we only have an allowance for the leads. Oh, I'll clear the... So to calculate the first source of uncertainty is that of the reference instrument. By this we mean if it's your reference DMM that you're using to make a measurement, or your reference calibrator that you're using as the source. So ProCal obtains data from all of these sources and combines them in the uncertainty template to create the final uncertainty. So in the example, the sourcing test, this is the multi-product calibrator, which is instrument 1 in the traceable instrument list. So this is the traceable instrument list in ProSet, and we've got selected instrument number 1, which is always the multi-product calibrator. And in this case, we've got a 4010 selected. That it doesn't matter what instrument you select, you will still have an uncertainty table for that instrument, either shipped with or you can generate your own. So each instrument, so this means a standard resistor, a pressure calibrator, whatever it is, can be configured to have an uncertainty table that lists each range and both the imported uncertainty and reference stability. So this screen is showing the editing, well, the viewing of an uncertainty table for the 4010. As we can see, we have, as I go through with the pen, so we have the index, the position in the uncertainty table, the description, so we have DC voltage 0 to 202 millivolt range, the range low, the range high. Where we have AC voltage or AC current, we have a low frequency and a high frequency. We then have the laboratory percent imported uncertainty and laboratory 0 imported uncertainty. And we have the reference percent of range error and the floor or 0 error. So each uncertainty line has fields for the imported uncertainty of percent of range and 0, as well as the reference percent of range or percent of reading and reference 0. In our uncertainty template, We then have an allowance for UUT resolution. This is calculated dynamically at runtime and is based upon the number of decimal places entered in the procedure in ProEdit. Obviously, the more resolution, the more decimal places the UUT offers, the smaller this contribution will be. We then have the fourth source, noise and flicker. So during a measurement, any kind of indicator will have an element of noise on the measurement, whether that's an analog meter, the needle moving a little bit, or on a digital meter, the last count moving. This is noise and flicker. We'd normally refer to this as counts. So there's 1 to 2 digits in the last count, the flicker of 2 counts on the meter. We can then start customizing the next 15 fields for entering additional sources of uncertainty. So I'm just going to run down a couple of examples here. So the first would be when you're measuring DC voltage, you must allow for the thermal effects of leads and interconnections. That would typically be a limit value of 500 nanovolts, for example. The second example would be when measuring temperature using a PRT probe. You must allow for both self-heating effects of the probe, because it's having current pass through it, as well as immersion depth, as that will have an effect on the measured temperature. And then third, we have a much more complicated template, where if you're measuring current using a current shunt, you must allow for the imported uncertainty of the shunt, the stability of the shunt, any heating effects on the shunt as it's having current applied to it. Heating effects, the current source will warm up if it's sourcing current for a long time, and that's all on top of the resolution of the measurement device and the measurement and the resolution of the source, the imported uncertainty of the measurement device, the error, the stability of the measurement device. So you can get quite complicated uncertainty tables quite quickly, which ProCal supports. So now we've got to the section of the webinar where we're going to run a live demonstration. So if you just bear with me 2 seconds, I'm going to switch over to ProCal. Okay, so I'm waiting for it to tell me everybody's got the screen. Okay. So in this procedure, I've got one meter type test, so where the calibrator is sourcing voltage, and one measurement type test, where we're going to be measuring current with the multimeter. So I click next, and I've just set my test. As we can see here, the orange bar is indicating test pass probable. This is because our uncertainty at 2.1 millivolts is much too large to be displayed on the screen. If we click our uncertainty button, we'll be able to view the uncertainty calculation and each contribution, and we can see, if I highlight with the arrow, we have a dominant effect caused by the resolution and therefore the noise and flicker. If we allow for 1.5 counts of noise and flicker, that is 1 millivolt of resolution and then another 1.5 millivolts because of the noise of the measurement. So I'm just going to clear my pen. What I'm going to do is I'm going to go and view this procedure in ProEdit, and I'm going to change the resolution of the UUT. So here I have my test selected. I'm going to go to ProEdit. So I have my test 1 of this procedure. I'm going to increase a number of decimal places from 3 to 6. So I'm going to switch back to ProCal. And I'm going to restart my test. So running the test again, we can now see the resolution has hugely increased and our uncertainty has decreased massively. So I'm just going to highlight that on the screen here. So we now have an uncertainty of 14 microvolts. If I click again on the uncertainty button, we can see the change that this has had on our budget. So we can see the resolution figure was 1 millivolts. It's now 1 microvolt. And now the main factor has become the error of the calibrator itself at 6.6 microvolts. So please, if you do have any questions, please don't hesitate to ask. What I'm going to do now is I'm going to add an extra contribution into my uncertainty budget. So at the moment we've got the standard 4 uncertainties, and then we have an allowance for connection and lead errors, and then we've got example contribution from the session earlier. So I'm going to switch into ProSet. So I have to show the full screen for this. I select my calibrator and I click the Edit Uncertainties button. And here we see our uncertainty table. Sorry, I got distracted there. I went off onto the wrong. I'm going to be showing you editing an uncertainty template first. The uncertainty template that we're using is the built-in default for DC voltage source. So over here on the left, if I leave a arrow, I'm going to be writing into this box, and I'll have an allowance for of 1 ppm, standard rectangular, distribution, and a confidence interval of 1. So I'm going to switch away from this. It has saved it. I'm now going to switch back to ProCal. Going to restart my test. It's come through as picovolts as it's too small. I'll create a large error. So I've just changed this now actually to update my short-term stability to a much larger figure so we can see it becoming dominant again in the budget. And we can see that our uncertainty has now expanded out. So you can see it's quite flexible what you can do with just modifying the uncertainty templates to best match up against your budget. Of particular note and of interest, that if you are going for accreditation and an auditor questions you how you developed this uncertainty that's displayed upon the certificate, clicking the uncertainty button here shows this spreadsheet which can tie up with your existing Excel spreadsheets if you've already developed uncertainty budgets in those. What I'm now going to go and do is adjust the calibrator uncertainty table. I'm going to edit the uncertainties from my calibrator, and in the line that we're presently using, the 200 millivolts to 2 volt range, I'm going to increase my reference error to 0.002%, so 20 ppm. I'll save the line back and I'll close. And now I'm going to restart my test. You see, once again, we've made the uncertainty larger again. So we've had a question come in. So after calibration, is it possible to see an uncertainties calculation list? So I'm going to have to ask for a little bit more elaboration on that. Do you mean on the certificate, or do you mean historically what the final uncertainty would have been? The way we perform this is to develop our schedule. We have a special procedure we run that lists our very best measurement capability, and then we can compare that every couple of months to make sure our uncertainty tables or our imported haven't had an effect on our schedule, making sure that it's never smaller than our published schedule. So I'm just going to erase all drawings. So I'm going to enter in 1 to proceed to the next test. What I'm now going to do is I'm going to proceed to our next test, where we are measuring current through a current shunt with a multimeter. So I click Next, click Start. As we're seeing, I haven't set the calibrator yet. So I've just turned the calibrator on, and we can see the sample starting to come through from the DMM. Now what we've got here is, once our final sample has come through, an uncertainty of 25 microamps. In our uncertainty budget, you can see we have some additional contributions. Please note these are just examples. But we have an allowance here for the imported uncertainty of our current shunt, an allowance here for the stability, the drift of this shunt between calibrations. We have a dynamically calculated noise and flicker based on the standard deviation of the 5 samples. And we have some additional contributions, so temperature coefficients, self-heating, that we've allowed for to develop our final uncertainty of 25 microamps in 1 amp, so 25 ppm. If I clear the drawings, we can see how dynamic the measurement is, in that I'm just going to start adjusting the calibrator, so deviating the calibrator to make the noise in these samples increase. And look at the size of the uncertainty bars as I do this. As we can see, the size of the uncertainty bars is increasing as our standard deviation goes up. Between samples, and we now have an uncertainty of 100 microamps because of the standard deviation throughout the most recent samples. And we now see this is reducing back down again now that the deviation between the samples has stabilized. To set ProEdit up to use a custom template rather than the default template. So normally this is performing a measurement, it will be using the DC current measurement template, but I've told it to use this special procedure. So I'm just going to switch over to ProEdit. and select this test, as we can see, we've set this measurement up to actually perform a measurement on the DC voltage range of the multimeter, but divide the resistance, the voltage measured, by the value of the standard resistor, and in the Advanced tab, we have set the uncertainty template as BMC DC current 100 milliamps to 1 amp, and the uncertainty line to make sure it uses the 1 volt range for the uncertainty line. What I'm going to do is switch this back now to use the defaults. So I'm going to clear the uncertainty template. I'm going to tell it to use DC current on the 1 amp range of my meter. I'm going to clear that to default as well. So now when I jump back to ProCal, and I click Restart Test, I reconnect my meter now to make a measurement directly rather than through DC current, DC voltage. Notice the connection diagram has changed without me having to do anything. As we're seeing, the error is still there because I have left the formula in place. So I'm just removing the formula from ProEdit and then restarting the test. So now the formula has been removed. We can see the measurement is a little bit different, but our uncertainty is much larger. So if I click Uncertainty, we can now see it's using the line for the multimeter from the table, and we don't have our additional contributions because we're using the default template. So I'm just going to break this for a second and share the next poll. I'd like to ask a couple of questions. Do you currently calculate uncertainties within your existing software? Okay, so I'm just going to wait for a couple more people to answer. We're just sitting slightly shy of 2/3 of people answering. Okay, right, I think I will call the poll to an end there. And I'll just share that from the information we've got, it looks like 1/3 of you are currently using your software to calculate uncertainties, while the remaining of those that did answer aren't using your software to calculate the uncertainties. So I can only assume that's presently being performed performed on spreadsheets, which is why we've designed ProCal to have this screen here that you can view in real time, so you can correlate it to your existing spreadsheet to make it easy to migrate over to calculating your uncertainties using the software. So as we've demonstrated, we can customize the uncertainty templates and add additional contributions. What I haven't demonstrated yet is how, when we click the uncertainty window, we have some extra buttons down here on the left: View Uncertainty Evaluation and View Procedure Manual. So if I click View Procedure Manual, this links to a PDF copy of your procedure manual for use during an audit. So if your assessor asks, can I see the procedure manual for this measurement for DC voltage, as well as the uncertainty, you can bring the uncertainty up on the screen and click the button, and it brings a direct link through to your procedure manual. But you can also, from ProCal, click View Uncertainty Evaluation, which in this case it doesn't have an uncertainty evaluation, so it's going to create a file for me. Then open it in Word. So if I add some additional uncertainty evaluations, I can write some information. So when I build my budget, if I take some measurements, I can import a graph, put this in the Word document, I save it, I go back to ProCal, and now when I click View Uncertainty Evaluation in my next review of my uncertainties, perhaps in a couple of years, now where did this contribution come from? I can't remember making these measurements. I must have written it down on a piece of paper somewhere. ProCal has taken care of that for you. So the system through which ProCal calculates the uncertainties is not just a calculator, but it's a full system that assists you through an audit, especially as if you have a more complicated budget with multiple contributions, and at the moment you're trying to manage all of these as Excel spreadsheets or PDFs or bits of paper in a folder. When the assessor visits, we always know that it's difficult to get through that. It's a stressful enough time as it is, and you need to be able to find that document at the click of a button. So that's why we've implemented these features. So as we're nearing the end of the webinar, I just want to launch one final poll, just asking that after this webinar, do you feel you will use your software more to calculate uncertainties? That the whole goal of this webinar was to explain how ProCal performs the uncertainty calculation. Although it is explained in the manual, sometimes having the visual guiding through writing a couple of uncertainties and customizing the budgets, seeing what the buttons do, we've found can really help in a controlled environment. So while that poll's open, I've got another question here. That we've got the procedure manual templates available. We can, on request, provide a Word document. Of course, the procedure manual is yours to create. So if you say, I'm going to create a procedure for measuring DC voltage, that is using your equipment, your laboratory references. It's not really our position to provide it in the software, but we can provide guides as to, well, here's the template we use. It won't have our information in there, but that's how we have done it. Okay, so I'm just going to leave the poll open for another minute just while we get some more answers. Okay, so I'll just call that poll to a close. I'll share that. Well, looking at the results that we did receive, it looks like now the vast majority of you, quite a change from the start of the webinar, is saying that there's now 80% is yes, that you will look at calculating the uncertainties within your software. So obviously this webinar has been of use to the vast majority of you. So I do have a question here that I see you are assessing the individual contributions to obtain the combined uncertainties. Can you discuss the assumptions you made about the correlation coefficients? ProCal only provides you with a template to enter your values into, so that is still based upon your particular uncertainty valuation at where you will enter those in. So ProCal provides, if I hop back over to ProSet, I'll share the screen. For example, we have a normal, a divisor by 2, and then a rectangular and root 2 and root 3 divisors, and you can vary the confidence interval on those, but you would still have to fall back to the numbers you would put in would have to be either limit values, or you can have them calculated based on the current reading. So you can enter a % of current reading, for example, or the nominal from a standard resistor. Okay, so I'm going to begin bringing the presentation to an end and leave the session with a questions and answers that I can continue to answer. Hopefully this webinar has been of use for the vast majority of you. That any feedback is greatly appreciated. We'll be sending out the codes to be used on the procedure store via email, along with a survey tomorrow morning once we've got the final attendee listing. So any questions, please feel free to ask them in the chat. I will stay online, and if there are any questions that I feel are good for the audience, I'll read them out and explain them.